Let's say on the same graph, you have two functions. Let's say one function goes like this, and the other one goes like this. And you want to work out the area between them. There's a rule which you can use. It's called the fx minus gx rule. Actually, I don't know if that's what it's called, but that's what I always refer to it as. I always refer to it as the fx minus gx rule. So one of your functions will be fx. The other function will be gx. Does it matter which way around it is? Yes, it does. You want the fx function to be the curve on the top. So if you notice, for the duration of, or for the limits, let's say, so we've got 2 points, 1 point here, 1 point there. Between those 2 points, my fx function is above the gx function, which is why I've labeled the red one as fx and the other one as gx. And that's kind of how you want to do it. So let's say in another graph, you have a curve like that, and let's say you have a straight line, and you're trying to work out the area underneath or between the two. Looking at the 2 points where they intersect, and that is now your interval, right? In this case, the straight line between that interval is above the curve between that interval. So the straight line would be the fx, and the curve would be the gx. And then you take it from there. You do the fx minus gx, and then you just integrate as normal between the two intervals that you might have. So let's have a look at that question. The diagram shows the finite region R bounded by the curve with the equation y equals 4x minus x squared and the line y equals 3. The line cuts the curve at points A and B. Find the coordinates of the point A and B. Can you try that? So you would make 4x minus x squared equal to 3. And now you just solve. X squared minus 4x plus 3 equals 0, which means x minus 3, that should be a 3, and x minus 1. So that means x equals 1, x equals 3. When x equals 3, y equals 3. And when x equals 1, y still equals 3. So the two coordinates are 1, 3 and 3, 3. That's A, that's B. Cool. Find the area of R. Between x equals 1 and x equals 3, between those 2 points, the curve is higher, it's above the line. So the curve will be the fx, the line will be the gx. So between 3 and 1, you're going to do fx, 4x minus x squared, minus, and then your gx, 3. And now you simplify that. So 4x minus x squared minus 3, 3, 1, and this is what you're integrating. So you get 4x squared over 2 minus x cubed over 3 minus 3x between 3 and 1. Stick it in your calculator, minus, do what you usually do, you get 1 1/3. But that's how it works. You find your intervals, you label which function is fx, which function is gx, and fx is always the one above. In your integral, you do fx minus gx, and then you do everything as normal. Okay, have a look at that question for me, please. Okay, you've got your interval -1 and 1. Your black curve is above your red line. So your black curve will be your fx. 9 minus 3x minus 5x squared minus x cubed. And then minus your gx, 4 minus 4x. Like this. Let's simplify that. 9 minus 3x minus 5x squared minus x cubed minus 4 plus 4x. And let's simplify it again. 9 minus 4 is 5. Minus 3x plus 4x is plus x. Minus 5x squared minus x cubed. We're going to integrate all that with respect to dx. 5x plus x squared over 2 minus 5 over 3 x cubed minus x to the power 4 over 4. Intervals 1 to -1. Sub it, subtract, do what you usually do with definite integrals, and you should get 20 over 3. And there you go. That is how you use the fx minus gx rule. That's how you work out the area between curves and lines. This will also be applicable to one curve and another curve, although that's more A2 stuff, but it's still the same process. And that is everything for integration.